welcome to Operational Research video series. In this video lecture, we shall talk about transportation problem, in which we transport various amounts of single homogeneous commodity from different sources to different destinations. What is the goal? We have to minimize the total cost of transportation. Some informations are given to us, like we know what is the supply of any origin, and remember that number is also fixed. Similarly, we know what is the demand of any destination, and that number is also fixed. We also know what is the cost of transportation of one unit of item from any origin to another destination. And before we go into deep details, we shall talk about the abbreviations that we shall use in this lecture. Like we use TP for transportation problem, TT, transportation table, and TC, the total cost. So let us recall some of the key points of this transportation problem. Like there is a linear programming form of transportation problem. However, no one talks about it, and the tabular representation is more popular among the students. So this is the tabular representation that you have. In this tabular representation, the sources or origins are in rows and the destinations are in columns. Like you may note that here you have M rows O1 to OM. Therefore, these are the OM origins of this transportation table. And similarly, we have N destinations from D1, D2 to Dn. What about the entries on the right side? You may note that on the right side, this entry A1 represents the supply of the origin O1. Similarly, A2 represents the supply of the source or origin O2, and AM represents the supply of the origin OM. What about the last row? In this table, in the last row, this B1 represents the demand of the destination D1, B2 the demand of destination D2. The rest of these entries in this row represents the demands of these various destinations. What about the cells in this table? Yeah, this is a matrix of size m by n. So there are mn total cells. You consider any one cell, like suppose you consider this cell. At this cell, C11 is the cost of transporting one unit of item from the first origin to the first destination. How many units do you transport from the first origin to first destination? Suppose you transport X11 units. Remember, the amount that you transport from any origin to another destination is placed in the northwest corner of this cell. Okay, so X11 amount you transport per unit cost is C11. So what is the cost of this cell? The cost of this cell is C11 multiplied by X11. Similarly, you can determine the transportation cost for the rest of these MN cells as well. The sum of these values is the total cost of transportation. Clearly, in this problem, we have to minimize this total cost of transportation, and therefore we have to determine how many units you need to transport from one origin to another destination. However, our main focus of this lecture is to numerically solve the transportation problem, and hence we better concentrate on its tabular form. Now some important results. Like, you know, a transportation problem is called a balanced transportation problem, where the total supply, what is total supply? The sum of the supplies from various origins must be equal to the total demand, that is the demand of different destinations like B1, B2 up to Bn. Therefore, sum of the supplies is exactly equal to the sum of the demands. Well, hence, what is the statement? It states that a necessary and sufficient condition for the existence of a feasible solution to a transportation problem is that total supply equal to total demand. We call it rim requirement, or the transportation problem has to be a balanced transportation problem. Next, another important result. The number of non-zero positive variables in a balanced transportation problem can be at most m plus n minus 1. You know already that non-zero positive variables in a transportation table are also called the basic variables. So there can be at most m plus n minus 1 non-zero positive variables or basic variables in your transportation problem. What about the rest of the variables? The rest of the variables are all zero. Acha, you can ask me, what if the number of these basic cells is less than this m plus n minus 1? Suppose that the number of basic cell is less than m plus n minus 1, then the transportation problem is called degenerate. Next, a very simple point, the solution of a transportation problem is never unbounded. As we have already discussed what is a balanced transportation problem, like where total supply equal to total demand, a case can occur where the total supply is not equal to total demand. You know, in that case, the transportation problem is called an unbalanced transportation problem. You can ask me, how do you make a balanced transportation problem? So why do you need to make it a balanced TP? Because it is the necessary and sufficient condition for the existence of a feasible solution. We have already discussed that. I hope you can remember. So we should note what you have to do when the transportation problem is not balanced. Remember, two cases can occur. Either your demand is greater than your supply. When the total demand is greater than total supply, we introduce a dummy origin. Now, if you introduce a origin, this origin must have some supply. What is the supply of the dummy origin? You assign the excess in rim requirement to that dummy origin. Suppose that, let us consider one example. Suppose the total demand is 200 units and the total supply is 170 units. That means total demand 200 is not equal to total supply 170. So the transportation problem is unbalanced. What you do in this case? You introduce a dummy origin with supply equal to 200 minus 170, that is 30 units. So this dummy origin will have supply of 30 units. Similarly, when the total supply is greater than the total demand, what you do? You introduce a dummy destination. What about the demand of the dummy destination? Remember, the demand of the dummy destination should be exactly equal to the excess in rim requirement. That means sum ai minus sum bj. Is not it? You want an example? No problem. Suppose you consider that the total supply is 300 units and the total demand is 250 units. So total supply 300 is not equal to total demand of 250. So the transportation problem is unbalanced. What you do? You introduce a dummy destination. What is the demand of the destination? The demand is clearly 300 minus 250, that is 50 units of demand has been assigned to your dummy destination. Another important concept, another interesting concept in case of transportation problem is that of a loop, which is a sequence of cells in a transportation table, and any two adjacent cells lie either in the same row or in the same column. No three or more consecutive cells in this sequence can lie in the same row or in the same column, and the first and the last cell of the sequence must lie in the same row or in the same column. In this case, you find that you are given a loop and this loop connects. This loop is being represented by these blue dotted lines which connects 1 cell, 1 cell, 2 4, 3 4 and 3 cells. You may note that there are 6 total cells and for being a loop you need at least 4 cells. What is the then you may note that any two adjacent cells lie either in the same row. Another major concept in transportation problem is that of a loop. Loop is a sequence. Another major issue in case of transportation problem is that of a loop. Loop connects a another major issue Another major point in transportation problem is that of a loop. This loop is a sequence of cells in a transportation table, and any two adjacent cells lie in the same row or in the same column, and no three or more consecutive cells in this sequence can lie in the same row or in the same column, and the first and the last cell of the sequence must lie in the same row or in the same column. You can find it graphically by these blue dotted lines. You find that this loop with blue dotted lines connects 1 1 cell, 1 3 cell, 2 3, 2 4, 3 4 and 3 1 cells, and clearly 1 1 cell back. Therefore, how many cells does it connect? It connects 6 cells. You observe that to form a loop that will satisfy these 4 criteria, you need at least 4 cells. Therefore, you observe you need at least 4 cells, that is loop involves at least 2 rows and at least 2 columns of the transportation table, and the total number of cells is always even. Finally, we are moving towards the solution to a transportation problem. You note that the solution to a transportation problem can be divided into 2 parts. First, you find out the initial basic feasible solution to your given transportation table. How many methods are there, or which method do you apply? Before that, there are various methods to determine this initial basic feasible solution. Like one can apply the northwest corner method, row minima method, column minima method, matrix minima method, or Vogel's approximation method, which is also known as VAM. You may note that after you determine initial basic feasible solution or IBFS by any of these methods, you have to improve your solution or check whether the solution is optimal. How do you test your optimality? To test the optimality of your IBFS, you use either stepping stone algorithm or UV method, which is also known as modified distribution method or MODI. Thank you for listening.